Hello everyone, welcome back to another GIS lecture video. And in this lecture video, I want to switch tactics a little bit. So we've already covered the concept of latitude and longitude, and we know that we can measure any location on a three-dimensional sphere, which we use to represent Earth, by stating a set of paired coordinates of latitude and longitude. So given our angles relative to the equator and the prime meridian, we can get pretty specific locations anywhere on a three-dimensional sphere. So let's talk about, now that we know what the measurements represent, let's talk about how we actually go about showing or writing down those angles, especially when we want to get more precise. So in terms of how we can write angles, there are two ways you're primarily going to see angles written. You're going to see angles written either one way, right, is going to be degrees, minutes, and seconds, right, degrees, minutes, seconds. The other way is going to be to see it written as decimal degrees. Right. So why do we even need these precise angular measurements? Right. So let's imagine for a second, right, that we have, right, this is 0 degrees north. We'll talk about latitude for a second. And this is 90 degrees north, right? And this is right. And this, right, is U. Right, let's say that, right, we have, right, let's say this is 45 degrees. I'm drawing this is not to scale, right, but this is 46 degrees, right? And so, right, precise measurement, right, you're not exactly 46, you're not exactly 45, you're somewhere in between. Right, so what precise angular measurements allow us to do is they allow us to record partial degrees, right, for when our angles are not whole numbers, right? So this is going to be when the angular measurement right is not a whole number. Right, for those times when, right, in this sort of exaggerated example, right, your latitude is more than 45 but less than 46. How can we record, right, this measurement? So the first way that we can do it is with degrees, minutes, and seconds. So let's go ahead and talk about that first. Give ourselves a little bit more space here. Give ourselves a little bit more space here. All right, so with degrees, minutes, seconds, what we do is we have the whole degree, right? So in this case, right, 45. Right, and then what we do is we say the distance between, right, 45 and 46 is broken up into 60 right, is broken up into 60 right, evenly spaced subangles, right? Let me redraw that a little cleaner, right? So we have one angle, and we have another angle, right? What we do is we break up into smaller subangles. And let's go ahead and put U back in here. Go ahead and put U back in here. So that's U. So what we do with degrees, minutes, seconds is we break this space between whole angles. So this is 45 and this is 46. Right? We add 60 subangles. I'm going to put subangles in quotes. Right? Between 45 and 46 in this case. Right? So this would be 45 degrees. That's the whole degree. And this one might be, 30 subdegrees in. And this would be, 31 subdegrees in. We call this first subdivision, we call this minutes. Right? So we start off with the whole degree. Right? And then we specify subdegrees called minutes. Right? So in this case, if this one's 30 and this one's 31, it would be 30 minutes. Right? Because we have 60 subangles. We divide the distance between 45 and 46 60 times, and we do the same thing, right? So we're between 30 and 31. We call each of these original 60 subangles a minute, right? So we're 45 degrees away from the equator, plus an additional 30 minutes. Right? But we're still not close enough, right? And so what we can do is we can take that and we can subdivide it further. Right? So if we were to subdivide it further, right? Again. Right, again. Right, so U would be here. Right? And so we know that, this is, 45 degrees, 30 minutes. And we know this is 45 degrees, 31 minutes. Right? We do the exact same process again, right? We go in between each minute, in between each minute, we create, 60 more subangles. Right? We divide this angle up into 60 subangles. Right? So we divide the angle between minutes, right? We create 60 more subangles. Right? Each one of these subangles is called a second. And so, right, if this was, let's say, 41, 42, 43, 44, 45, right? So you would be at, right, seconds, right? You would be at 43, right? So we can measure your angle based on the whole degree, right? The partial distance to the next degree broken down 60 subsections called minutes. Then the progression to the next minute broken down 60 into 60 seconds, right? So to put this another way, right, we have a whole degree, the space between degrees. Let me actually make this right. So we have a whole degree, right? Between degrees is broken up into 60 minutes. Right, space between degrees broken into 60 minutes. Right, space between minutes broken into 60 seconds. And so dictating your position based on your whole degree, your progression to the next degree in terms of the number of minutes, your progression to the next minute based on the number of seconds, this gives you a much more precise measurement. Right? If you dictate somebody the number of seconds, you're going to be really, really close to that person's location. So we can specify a precise angular measurement by giving the whole degree, the progression to that next degree in terms of the number of minutes along the angle, the progression to the next minute in terms of the number of seconds along to the next minute. So hopefully that makes sense. It'll make more sense when we go talk about conversion to the other way that we can measure angles, which is to talk about decimal degrees. Now, decimal degrees, to me, are a little bit more intuitive, because with what decimal degrees does, if we go back to this example here, and I want to make it a little more clear that right, you are this angle right here, this angle right here is you. Right, so you're here, right? That if we estimate, right, between 45 and 46, you're approximately halfway, right? Approximately halfway. Between right 45 degrees north and 46 degrees north. So what decimal degrees would do is it would say, okay, give me the whole degree. Right, so in this case, right, 45 degrees. And then it would say, give me as a decimal how far along to the next degree. So in this case, right, we're approximately halfway, so that would be 45. So a decimal degree would read as right 45.5 degrees north. So it gives you the whole degree. And then it gives you, right, the fractional portion of the next degree. Right, so you can see that we have two different ways that we can approach dealing with writing measurements that are not whole angles, right? Again, the impetus of precise angular measurements is when the latitude or the longitude is not just a pure whole number, right? When we have a portion of another degree, we can either represent it as the whole degree plus a decimal representation of the portion to the next, or we can write it as the whole degree plus the space broken down into 60 plus the space broken down into another 60. So if this doesn't make sense at first, that's okay. Pause the video, try to kind of wrap your head around conceptually what's going on here. As we talk about another way that we can approach this is to think about it through the idea of conversions. So let's go ahead and talk about how we can convert from degrees, minutes, seconds to decimal degrees, right? So how we can go from one to the other. And I think this is going to highlight how the different approaches are constructed. And hopefully you'll all come away with a better understanding of how each one works. Right, so we start with degrees, minutes, seconds. So we're doing degrees, minutes, seconds, which we can abbreviate as DMS. And we're going to decimal degrees or DD. Right, so DMS or degrees, minutes, seconds. And we're going to the concept of decimal degrees or DD. So if you see DMS, degrees, minutes, seconds. If you see DD, think decimal degrees. Right. And so with degrees, minutes, seconds, what you're going to have is you're going to have X degrees, Y minutes, and Z seconds, right? And you want to convert that to X degrees and then some decimal point, some fraction progress to the next degree. Right. And so this is relatively straightforward, right? To do the conversion process, right, we keep the X number of degrees by itself, right? Nothing changes here, right? This whole degree does not change. Right? So this whole degree is the same as that whole degree, right? We're not changing the whole degree. Instead, what we're doing is we're converting this Y and Z are going to become, right, the fractional part or the fractional progress to the next degree, right? Because we know we're at some degree, but then we also know that we went past that a little bit. Well, what did we go past it? We went past it Y minutes and Z degrees, right? Now, if we think conceptually what each of these represent, right, going back to the previous slide, right, we know that there are, by definition, right, there are 60 minutes in a degree, right? We literally just talked about the concept, right? That we take the original degree, we break the distance between 2 degrees into 60 subangles. We call each subangle a minute, right? So we know that, right, in terms of the fractional progress to the next degree, we know that, right, y over 60, right, y over 60, right, so x, right, plus, right, y over 60, because there's 60 minutes to the next degree, right? We also know, right, that we went some number of seconds into the next degree, right? And so we know, right, that there are, right, by definition that we just talked about, right, there are 60 minutes, or sorry, seconds, right, in a minute. Okay, so there are 60 seconds in a minute. We know this by definition. So if there's 60 seconds in a minute and there's 60 minutes in a degree, right, we can combine these two pieces of information to say 60 seconds in a minute times 60 minutes in a degree means that we have 3,600, right? Because 6 times 6 is 36, right? 3,600, right, seconds in a degree, right? And so what we can do is we can take that information and say, well, we know that we have gone, right, y over 60 fractions towards the next degree, but we also went, right, z over 360 to the next degree, right? And so if we do this, right, the whole degree plus minutes over 60 plus seconds over 3,600, that will give us, right, our decimal degrees. Okay, so if that doesn't immediately make sense, let's go ahead and look at 2 example problems. Let's look at the problem of 28, 30, and 30, and 45, 45, 15. So 28, 30, and 30, you're going to have 28, right? Because again, we just pull down, right? We pull down the, right? We pull down the whole number part plus, right, 30 over 60, right? Because there's 60 minutes in a degree, and we have 30 minutes in this particular problem, so 30 over 60 plus, right, 30 seconds over 300 or 3,600, right? Because there's 3,600 seconds in a minute, or in a degree, I'm sorry, right? So if we do the math on that, right, it's 28 plus 30 over 60 is 0.5 plus 3 over 360, right? We do 3 over 360, right? Gives us 0.008, right? So if we do the math on that, we get, right, 28.508 degrees. Right. In this case, we're not worried about north, south, east, or west because we're just talking about mathematical conversions, right? But to go from 28 degrees, 30 minutes, 30 seconds, 28.508 degrees is the conversion. So let's go ahead and do another one, going from 45, 45, 15 to decimal degrees. So we're going to do the exact same thing. We're going to start with 28, or sorry, not 28, that was the previous problem. We're going to start with, 45 plus, we're going to pull 45 from the problem, so this 45 goes there, over 60, because there's 60 minutes in a degree, plus, 15 seconds over 3,600 degree, or seconds in a degree. So if we do that, we get 45 plus, 45 over 60 gives us 0.75. Plus 15 over 3,600, gives us 0.004. 0.04, So if we do the math on it, if we add that up, we get 45.754 degrees. Okay, so that's how we go about converting from degrees, minutes, seconds to decimal degrees. So let's go ahead and go the other way. Let's go from decimal degrees to degrees, minutes, seconds. This one is a little bit more complicated in terms of the approach, but I think it largely makes sense. So just like before, we have some number x, with some decimal points, And so what we're going to do here is we're going to do this in 3 steps, So step 1, and our goal is to go to degrees, minutes, seconds. So step 1, the degrees is just the whole number. In DD. So this x here, it's going to go there. So we know this is x degrees, Step 2, we're going to multiply the decimal part by by 60 to get the number of minutes. So we do the dot d, d, d. So that is coming from, let's use a different color. So this part here from the original number, is coming down here, And so we're going to do DDD, times 60, Let me do that so that there's this is multiplication, times 60, is going to give us some whole number, and some new decimal points, which I'm going to call z, 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 So this, right, whole number y here, right, this is the number of minutes. Right, so we'll have y minutes. All right, and then step 3, right, multiply the decimal part of step 2 to get, right, the number of seconds. Right, and so what that's going to look like, right, if we use a different color again here, right, this .zzz part, right, is going to come down here, right, and we're going to do, right, dot zzz times, right, and again, this is multiplication, 60, right, is going to give us, right, some whole number, which I'm wishing I hadn't used it here. Let's call it how about A dot, right, and there's going to be some decimals, right, some decimals, right, this whole number A here, let's use purple. Purple sounds like a good number, a good color, right, this A here, right, this is, right, the number of seconds. Right, so to sort of take a step back and understand the process, right, given some whole number degree plus a decimal portion to the next, the first thing we do, we take that whole number degree, that's the number of degrees in minutes, seconds. That doesn't change. Next, we take whatever decimal portion of degree, whatever proportion to the next degree we were gone, we multiply that by 60 to get the number of minutes. Right, that whole number part goes, and that's the number of minutes, right? The decimal portion, or right, the proportion of the fraction to the next minute that we went gets multiplied by 60 again, and that whole number becomes the number of seconds. If that doesn't make a lot of sense right away, pause the video, rewatch the part, and we will also go through 2 examples that will hopefully make it more clear. So let's go ahead and go through those 2 examples. So given, right, the number 35.52, right, let's go ahead and convert from decimal degrees to degrees, minutes, seconds. Right, so we're going from DD to DMS. Right, so we know we're going to ultimately end up with degrees, a minutes, and a seconds. And our answer is going to start with 35.52. Right, so think back to the 3 steps. The first step, you pull off the whole number of degrees from DD, and that becomes the number of degrees in DMS. Right, so this 35 is this 35. Right, to get the number of minutes, right, we take the fractional portion, which in this case is 0.52. Right, so we have 0.52, multiply that by 60, right, because there's 60 minutes in a degree. This is the proportion to the next full degree. If we do the math on that, right, we get 31 0.2 minutes, right? We take the whole number from here, and that becomes our number of minutes, right? And then we take the fractional proportion to the next minute, so this 0.2, we multiply that by 60, right? Because there's 60 seconds in a minute, right? And so if we take 60 and multiply by 0.2, right, we get 12 seconds, right? 12 seconds, right? So 35.52 decimal degrees translates to 35 degrees, 31 minutes, 12 seconds. So hopefully that makes sense. Let's go ahead and look at another example to try to make things a little more clear. So we have 152.45 degrees. And again, we're going from, decimal degrees to degrees, minutes, seconds. Right? So again, we know we're going to end up with a number of degrees, a number of minutes, and a number of seconds. And we know that we're starting with 105.2 or 152.45. So the first thing that we're going to do is we're going to pull this 152 off, right? Because the number of whole degrees doesn't change, right? And we know that we were 0.45 or 45%, 0.45 progress to the next degree. And we know there are 60 minutes in a degree. So if we multiply 0.45 by 60, right, we get that we are 27 minutes, right, to the next degree. So 27 minutes. And then you'll notice, right, that there is no decimal point. Right, you'll notice that there is, right, no decimal. Right, no decimal means, right, 0 seconds, right? Because this is equivalent to 27.0, right? Bring that down, right? 0 times 60 equals 0, right? So if you have no decimal, that means that the end result of that would be, right, 0 seconds. So 152.45 degrees translates to 152 degrees, 27 minutes, 0 seconds. So hopefully that made sense. As always, if you have any questions, please reach out. Thank you.